Hello and welcome. Today we're looking at how to determine the degrees of unsaturation. So anytime you have a double bond, then it will have 1 degree of unsaturation. So in this structure where you have 2 double bonds, that will have 2 degrees of unsaturation. Now if you have a triple bond, that will be also 2 degrees of unsaturation. Anytime you have a cyclic system, that will be 1 degree of unsaturation. That will also be 1 degree. If you have a cyclic system and a double bond, so 1 degree for the cyclic system and 1 degree for the double bond, and that gives you 2 degrees of unsaturation. Now in this structure, where you have one cyclic system fused with another cyclic system, and then let's say you have a 3-membered ring, you have a double bond there, you have a triple bond here, and you have another double bond there. We said each triple bond is 2 degrees, each cyclic system is 1 degree, then each double bond is 1 degree, and each cyclic system is 1 degree. So if we count, that's 2, 3, 4, 5, 6, and 7. So that has 7 degrees of unsaturation. Now the degrees of unsaturation can be calculated as, so I'll say degrees of unsaturation equals to number of missing hydrogens. So number of hydrogens that's missing divided by 2. Now if you have a structure C5H12, we see that fits this formula CnH2n plus 2, where n is 5, so 5 times 2 is 10 plus 2, and that's 12. So that means if this structure is satisfied, then the number of missing hydrogens equals to 0. So in that case, the degrees of unsaturation equals to 0 divided by 2, and therefore 0 degrees of unsaturation. Now if you have this formula C5H10, so the degrees of unsaturation equals to number of missing hydrogen. So we saw that if n is 5, then 2n plus 2 is equals to 12, so we expect 12 hydrogens, but here we have 10, so that's 12 minus 10 divided by 2, which is 2 divided by 2, and that's equals to 1. So that it has 1 degree of unsaturation. Therefore, that means that structure can be a cyclic system with 5 carbons, or it could be a straight chain with 1 double bond. Another example, if you have oxygen, let's say 3 oxygen, the number of oxygen does not count. So you don't look at the oxygen. So in this case, we'll still have 10 hydrogen, and therefore we expect 12 minus 10, which gives you 2, and it will still be 1 degree of unsaturation. But now the structure has 5 carbons with 1 degree. So it could be a cyclic system with 5 carbons, and then you have 3 oxygens. Or you could even have an ether, still has 5 carbons, and then you have the other oxygens. So there are multiple ways that you can draw those isomers. Now if you have a halogen, say Br2, each halogen counts as 1 hydrogen. So in this case, we'll have 10 hydrogen plus the 2 halogens, and therefore that will look like you have 12 hydrogens. And we already saw that we expect 12 hydrogens, so minus 12, which equals to 0, and therefore this structure will have 0 degrees of unsaturation. That means no cyclic system and no double bond. Lastly, if you have, say, 2 nitrogens, then we expect, because it's a C5, we still expect 12 hydrogens. But now the number of nitrogens will be subtracted from the number of hydrogens. So in other words, you take 10 minus 2 nitrogens, which equals to 8, And therefore, this looks like it has 8 hydrogens, and therefore it will be 12 minus 8, which gives you 4 divided by 2, and that gives you 2 degrees of unsaturation. So in summary, number 1, we've said, look at the number of missing hydrogens. Number 2, if you have halogens, which I'll call X, that will be fluorine, chlorine, bromine, or iodine, you count them as hydrogens. So you add them to the number of hydrogens. Number 3, if you have oxygen, then that does not count. And number 4, if you have nitrogen, for each hydrogen you subtract hydrogen. So you subtract 1 from the number of hydrogens. So minus 1 for hydrogen. Thank you very much. If you enjoyed this presentation, please like the video and also subscribe.